works. So you can see, can you see now, as soon as the value becomes less than 5, it becomes 0. And because that's linked straight up to the rotation on our door, you can see the door opening and closing as we get close to it. So at the moment you can see it's working the wrong way around. So what we need to do is first of all change our expression. Let's put it as a less than 5. So now you can see as we're far away from the door it's closed, and as we get closer it opens. Now also 5 units is a bit too much, so let's reduce this. Let's take this down to say 2 meters. So then as we get closer, when we're 2 meters away it opens, and when we're less it closes. So this is fine, but at the moment also the door isn't really opening enough. So what we need to do is increase that value at the moment. At the moment it's just 1 and 0. 0 is fine for being closed, but 1 isn't really enough. So what we want to do now is add another expression value on top of that. So this is quite useful. You can put a more complex expression in one expression value, but often it's useful to use multiple expression values so that you can split up the math, and so it's easier to read afterwards. What I can do here is just a times 1.5, and so what it's going to take is the result of our first expression value here and multiply it by 1.5. So you can see now our door is opening a lot wider than it was before. Still not probably wide enough, so let's increase that a little bit more. Let's put 2. Okay, that's pretty good. So now it's opening and closing fine. The next thing we need to do though is get it to move a bit more smoothly. So let's get our inertia channel again, because this is perfect for that. And let's put that in between our top expression value and the rotation vector. So let's first of all try that out in default. So you can see it's opening and closing more smoothly now. It's not instantaneously opening and closing. Let's give it even more damping though, because that's far too fast still. So with 0.2 you can see this is looking a lot better. So now as we come close to the door it opens, and as we're inside the house, again as we get further away it closes. As a final step, we'll look at how we can disable the HUD when we're outside of the house. So to do this we first need to look at a new channel. So let's go to our tutorial 4 channel group and go to the channel list, and what we're looking for now is the collision ray channel. Now if we get this, you can see the collision ray check channel, that's the one we want. So if we drag that into the channel graph, you can see this one has quite a few child link positions. Now basically what this channel does is it will shoot a ray out in a direction and a distance which you specify, and then what you can do is check whether that ray collides with any particular object. So if what we do here is give the ray the position of our camera and then shoot it down beneath the camera by a couple of meters, we can then check whether it has had a collision with our house object. So then obviously if it has had a collision with our house object, it means we're inside of the house, at which point we can then display our overlay for the light switch. So let's have a look at doing that. Now the first child link position here is the position from which the ray is going to be cast. So this is where we want the camera's position. So let's go to the dual view channel graph and go over to our camera, and we've got the out movement position of our camera here. So we'll link that up to the first child link position of our collision ray check. Now the second child we need here is a movement vector. So this is basically which direction the ray is going to be shooting out at. So again we need a value vector. So let's get a value vector from the channel list, and let's connect that up to the second child link position, and I'll just give this basically let's give that -2, something like that. That means that this ray will be shooting out 2 meters underneath our camera. Now the next thing we need to do is specify what we want to be looking for the ray to be colliding with. So in this case it's our house inner objects. We want to see if our ray has collided with the floor of our house. So let's now go to the dual channel view, and in here we can select the third tutorial group and now let's go and get our house inner object, and we're going to connect this up to the collision ray check. Now let's go back to the big channel view, and you can see here we have our collision ray check, and what we need to do now is collect a collision object channel up to our collision ray check. So let's go down and get a collision object channel, and this is what we need to connect up to our collision ray check, like that. Now basically this is how these channels need to be connected. You connect the house inner object up to the collision object, and then the collision object is connected to the collision ray check. So now that we've done that, we're pretty much ready to go. So before we connect it up, let's have another look and see how this system works. So basically we've got a ray that's going to be shot down from the position of our camera here. It's going to be shot down -2 units in the y-axis. So it's basically going 2 meters underneath our camera, and it's going under there and it's checking whether this ray has had a collision with our house inner object. So in this case it will be looking down to see whether the ray has had a collision with the floor. If it has had a collision, then the value of our collision ray check will turn to 1. If it hasn't, then it will turn to 0. So we can use that value to turn our render on and off for our overlay. So let's have a go at doing that now. So here's our render. We want to be able to turn this on or off. So to do that we need some kind of a logic channel above there. So what we're going to do is use the if channel. Now the if channel, basically what it does, it calls all of its second child or any of the children after that if the first child is 1 or greater. So if we connect this up here like that, what's going to happen is it will call the render if our collision ray check provides a value of 1 or greater. If it doesn't, then it won't call our 3D render channel. So whilst this is now set up correctly, our if channel isn't being called. So what we need to do now is go back to the dual channel view and get our start group up here and link it up properly. Now at the moment we're calling our render straight away from our start group. We no longer want to do that. We want to call the if channel instead. So I'm going to delete the public channel from there and connect the if up like that. Now you can see we've got the if channel connected straight up to our start group, and so that's where our logic's going to start from. It's going to use our collision ray check to see whether a collision has occurred, and then that in turn will decide whether the render is turned on or off. So let's go to the animation section or to the channel view and have a look and see if this works. Yeah, you can see it is working. So when we're outside of the house, our collision ray check is giving a value of 0 because a collision has not occurred, and as soon as we go into the house it's giving a value of 1 because a collision has occurred. Therefore the if channel is calling the render and our display is turned on. We started this tutorial by creating a simple on-off switch. We then used this switch to switch between 2 different light maps. We then created a HUD for the scene. We then created an automatic door for our scene which opened and closed depending on how far away from it we were. Finally, we created some logic to disable our HUD when we were outside of the house. In the next tutorial, we're going to import a ceiling fan and a wall dial to control the fan into the scene. We're then going to make our ceiling fan rotate and then make the dial on the wall control the rotation of the ceiling fan. We're then going to import a TV and use a movie file for its screen texture.